Welcome. This video demonstrates the process of connecting and visualizing the connectivity of different subassemblies in ANSA, utilizing the specific ANSA entity types. Usually, each subassembly is handled as a different model or include file, often by different users or even working teams. Those subassemblies finally need to be ultimately merged and connected into a common final assembly. In this video we will demonstrate such a case, to apply connectivity between the door and the side panel of a vehicle subassemblies. On this direction, there are dedicated ANSA entity types, which can be used to connect different subsystems, assembly points and connectors. Assembly points are ANSA entities that are designed to signify the subsystem's parts locations where the FE representation of the actual connectivity is going to be placed, while connectors are ANSA entities that are used to connect different subsystems together in a common assembly. First, in our example, the assembly points are defined in the hinge part of the door subsystem. To perform that, open the Assembly ribbon tab, click on Assembly Point and create a new entity. There are multiple ways to create assembly points, such as on COG or on element. ANSA also features the On Holes, Auto, option, which automatically detects potentially existing holes and is presented in this video. In this functionality, we define a range that covers the part's holes diameter values and the assembly points are automatically created. You can also define the assembly point interface type from the window itself. While in preview mode, the assembly points are pending and not yet applied. Middle mouse click again to apply representation, completing the generation of the interface elements. The generated entity's color turns from orange to green, indicating that their status has changed from empty to applied. Note that an assembly point can optionally assign a name or node ID to the underlying node, for future reference. You can also modify the interface type from the assembly point's window itself, or alternatively, from the individual window of each assembly point. Once the assembly points are created, save the new file version. Now that the assembly points of the first subsystem are created, the process is repeated accordingly on the second subsystem. That ensures that when the two subsystems are merged, the connectivity process is simplified. You can also import the subsystem, for example as an include, into the existing file. Again, using the On Holes Auto functionality, the assembly points are created. Save the updated file version. After this point, each individual subsystem has the necessary assembly points, pending to connect them together into a common model, using connector entities. Merge the new versions of the subsystems together. You can switch to subsystem view to clearly illustrate the two different subsystems that now coexist in the merged model. Click on Connector. Use from a Points, Auto, to automatically create the connectors. The latter are created based on the assembly point's distance proximity, the value of which you can edit. Additional constraints can be also checked, such as connecting assembly points only when having identical names. Again, you can define the representation type of the created connectors from the connector entity window. Or alternatively, you can right-click on the representation column in the connector entity window to define, or modify, the representation type. You can apply the defined representation type on multiple connectors simultaneously after selecting them, through the right-click context menu. You can also utilize a connection template if you already have one set up for connectors. As soon as the FE representation is successfully applied, the two subsystems are connected together into the final, common assembly model. To ensure the connectivity was successfully applied, you can run the corresponding connectivity check from Checks Manager. Note that other connections between parts in each subsystem also exist, but are not being displayed for visualization convenience. The task of generating the connecting elements to connect the two initial subsystems is completed. For more information on subsystems assemblies and modular run managements in general, visit our corresponding playlist on our YouTube channel. Thanks for watching.